Okay, ladies and gentlemen of algebra, this is Unit 8, Note 1, talking about simplifying radical expressions. So, learning target simple enough, I can simplify a radical expression. So, a radical, remember, looks like this. It looks like a division sign, but it's got a little tail to it. So, as we start thinking about this, I want you to start off with what is a prime factorization of each of these numbers. So when I say prime factorization, that means break it down to just prime numbers. That means nothing that can be divisible by any other number except the number itself. Okay, so 63, I can split apart into 9 and 7, but 9 is still not prime, so I can break that down into 3 and 3. All right, 98. There's a couple different ways I can go here. Probably, if you're clever and just divide it by 2, you can go 49 and 2, but 49 can be split into 7 and 7. 180, I'll do this one because it's easiest. 18 and 10. Obviously, you can go like 90 and 2 and keep going a whole bunch of different ways with that. So 18 can be split into 9 and 2, 10 can be split into 5 and 2, 9 can be split into 3 and 3. So there's my factors. Okay, so prime factorization will be written as 3 squared times 7. This will be 7 squared times 2. This will be 3 squared times 2 squared times 5. Those are the prime factorizations. That's what they have to look like. Go. Oh, too far back. So radical expressions, anything with a radical term. Simplified form says no perfect squares underneath the radical, no factors that I could pull out that I could take the square root of, no fractions under the radical, no radicals in the denominator of a fraction. So simplifying means find the prime factorization. If there's a variable with the power, write it in expanded form. Pull out any pairs from the radical. So if I look at 50, 50 can be rewritten as 25 times 2. I can rewrite that all underneath the square root. Now the rules of square root also say that I can rewrite this as square root of 25 times square root of 2. 25 is 5 times 5. I can also write that as 5 squared. I've got the square root of 5 squared, which is just 5. You might have also recognized that as the square root of 25 is still 5. So simplified is going to be just this. 48 is another one. 48, I would like kids to recognize that this is going to be 16 and 3. And then I can go 4 and 4. Then I can go 2, 2, 2, 2. So I go 2, 2, 2, 2, and 3. So it's going to be 2 squared times 2 squared times 3, all underneath the square root. So square root of 2 squared, square root of 2 squared, square root of 3. Square root of 2 squared is just 2, square root of 2 squared is just 2, times square root of 3. So that one's just going to be 4 square root of 3. But as you get more comfortable with this, you can recognize that, hey, 16 is a perfect square root. I can take the square root of 16, that's going to give me 4. So my answer is going to be just 4 square root of 3. Same kind of idea with 32. A lot of you guys say, well, 4 works. 4 is a perfect square. That's going to be 8. Number one wrong answer I'll get here is kids will do this. They'll take the square root, and then I'll leave 2 square root of 8 and expect that to be the answer. The problem with that is that you can keep going with that. So that's going to be 8 can be split apart into 4 and 2. So that can be square root of 4 times square root of 2. Square root of 4 is still 2 times square root of 2. So my answer should really be square root of 2. All right, now if you're clever, you can realize that square root of 32 is going to be 16 times 2. And square root of 16 is just 4, and you still end up at the same spot. So anytime there's a variable, here's kind of where it's important to recognize what I'm doing. X to the fourth can be split up into x squared and x squared. All right, square root of x squared is just x, square root of x squared is just x. I'm multiplying, so together that gives me x squared. All right, the other thing to remember is this. All right, and this is kind of a different, unique look at it. Square root is actually the equivalent of saying an exponent of 1/2. Okay, so if I say square root of x, that's the equivalent of saying x to the 1/2. So here for number 7, different way kind of thinking about it. This is like saying take x to the 4th and raise it to the 1/2. Well, think about rules of exponents. When I raise a power to a power to a power means I multiply. So 4 times 1/2 is going to be 2. So just kind of a unique way to think about it if you really want to think, about it that way. So here, let's split this apart. So 4b cubed, so I'll take this as square root of 4, and then b cubed can be split up into b squared times b. I do that for a reason. Square root of 4 is nothing more than square root of 2 squared, so it's going to be just 2. Square root of b squared is just going to be b times square root of b. So it's going to be 2b square root of b. Here, well, let me go back and look at this one. So same kind of idea I did here in the red. So if I wanted to do 4 raised to the 1/2 and b cubed raised to the 1/2, I took each part. Well, realize that 4 is really 2 squared raised to the 1/2 and b cubed raised to the 1/2. That's going to give me just 2, and then this is going to give me b to the 3/2. Well, if I pull out 1, I'm left with b to the 1/2. So that's 2b, and then to the 1/2 is just square root of b. All right, so either way, however you feel comfortable with it. So 75, that's going to be 25 and 3. So that's going to be 5 square root of 3. Oh. So then x squared, now let me let's get a little room here. So square root of 75, 25 and 3. So that's 5 square root of 3. X squared is going to be square root of x squared. So it's just going to be x. And then y cubed splits apart into y squared and y. So if I square root that, square root of y squared is y. So here's what I've got. I've got 5 times square root of 3 times x times y times square root of y. Here is where I put together what's on the outside. I put together what's on the inside, and there's my winner. So simplifying radical expressions using perfect squares. The product property, which I've already talked about a little bit, you cannot do, you can only do the perfect squares. All right, determine the largest perfect square that works. So here we go. 1, 4, 9, 16, 25, 36, 49. You guys should be expected to know these. 144, 169, 196. 15 15 is 225. 16 16 is 289. 20 times 20 is 400. 17 squared, a little bit tougher to figure out, but you guys should know this. 17 squared, 18 squared, 19 squared, by far the hardest ones to remember. So 17 squared is going to be 289. Sorry, 16 squared is going to be 256. 18 squared is going to be 324. 19 squared is going to be 361. So at least know up to 15, okay? And the popular ones like 20. So square root of 24, biggest perfect square that works is going to be 4. So I split that apart into square root of 4, square root of 6. So it's going to be 2 square root of 6. That's simplified. Thank you for playing. 98. Everyone thinks, well, does 9 work? No, 9 does not work. But if I divide it by 2, I get 49. So that's kind of a happy coincidence because 49 is a perfect square. So my answer will just be 7 square root of 2. 3 square root of 18. Everyone always likes to forget the 3 out front. So if I simplify square root of 18, I'm going to simplify that into square root of 9 times square root of 2. But I'm keeping this 3 along the way because remember, I'm multiplying all these things. Square root of 9 is a fancy way of saying 3. So after all that, I get 9 square root of 2. Number 13 over here, 5 square root of 12. Bring the 5 along, people. You'd be amazed how many people forgot that and then do not add it in their answer. I'm going to split 12 into 4 and 3. Square root of 4 is a fancy way of saying 2. So my answer will just be 10 square root of 3. All right, so take a look here. A tsunami is a destructive, fast-moving ocean wave that is caused by an undersea earthquake, landslide, or volcano. Scientists can predict arrival times of tsunamis by using this thing right here. S equals G, square root of G times D. So where D is the depth in meters and G is 9.8 meters per second. Find the speed of tsunami in a region of the ocean that's 1,000 meters deep. Write your solution in the simplest form. So remember, this is 9.8. So D is the depth and G is your speed. So you're looking for the square root of 9.8 times 1,000. So you're looking for the square root of 9,800. So I'm going to split this apart. I'm going to split this apart into 3 things. I'm going to split this apart. Square root of 49 times square root of 100 times square root of 2. That's going to be 7. That's going to be 10. That's going to be square root of 2. So simplify, that's going to be 70 square root of 2. All right, and I can do that because I can do 3 of them. So number 2, or letter B, find the speed of a tsunami that is 4,000 meters deep. Write your answer in simplest form. So same kind of idea. 9.8 times 4, or not, yeah, 9.8 times 9.8 times 4,000. So 39,200. Split that apart and let's see what works there. 39,200. So if I divide it by 100, that gives me 392 and 100. 392 can be divided by 4. So it can also split like this, square root of 196 and 2. So now square root of 196 is 14, square root of 100 is 10, square root of 2 is just square root of 2. So this is going to be 140 square root of 2. I multiply the 10 and the 14 because I took the square root of those. Those are on the outside, so I can multiply them. So, critical thinking. The speed of tsunami is 4,000 meters deep, 4 times the speed of the tsunami that is 1,000 meters deep. Why or why not? So if you look back at your answers, is the 4,000 meters deep 4 times the speed of the one that was 1,000? Yes or no? Why or why not? Why do you think so? So take a minute, think about that before we go on. That's all I got. Thank you for playing. Come talk to me with questions and take your time with this because it is not easy.